NFPA 70, also known as the National Electrical Code, specifically Article 500, deals with hazardous classified locations. Section 500.8 C2 requires a Class 1, Division 2 classification for indoor areas where flammable gases are handled, processed, or used. ANSI/NFPA 30, the Flammable and Combustible Liquids Code, Section 6.12, similarly classifies indoor areas with unconfined flammable gas as Class 1, Division 2. The AGA classification of gas utility areas for electrical installations, specifically Table 1, also classifies indoor areas where natural gas is present as Class 1, Division 2. The presence of natural gas in an indoor area, even at pressures below its lower flammable limit, or LFL, creates a potentially hazardous atmosphere. Gas detectors alone cannot eliminate this hazard because they only detect the presence of gas, not prevent it. In the event of a leak or other release of natural gas, the gas concentration could rapidly rise to levels that exceed the LFL, creating an explosive atmosphere. Class 1, Division 2 classification requires the use of explosion-proof electrical devices to prevent ignition sources. Class 1 locations are those in which flammable gases, flammable liquid-produced vapors, or combustible liquid-produced vapors are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Division 2 locations are those in which ignitable concentrations of flammable gases, flammable liquid-produced vapors, or combustible liquid-produced vapors are present but under abnormal operating conditions. These abnormal conditions might include rupture or failure of containment equipment. The key is the potential for an explosive atmosphere under normal or abnormal conditions. Gas detection systems can be used as part of a comprehensive safety system, but they do not replace the need for proper area classification and explosion-proof equipment in Class 1, Division 2 locations. Gas detection systems provide an alarm or shutdown function when gas concentrations reach a certain level. This allows personnel to take corrective action and prevent an explosion. However, gas detectors can fail and there may be delays in response time. Explosion-proof equipment is designed to contain an explosion within the enclosure and prevent it from propagating to the surrounding atmosphere. This equipment is tested and certified to meet specific standards for use in hazardous locations. The combination of gas detection and explosion-proof equipment provides a higher level of safety than either measure alone. In a Class 1, Division 2 area, all electrical equipment must be rated for use in that environment. This includes lighting, rotors, switches, and other devices. Explosion-proof equipment is designed to prevent explosions from occurring inside the device from igniting the surrounding atmosphere. Intrinsically safe equipment is designed to limit the energy available in the circuit to a level that is too low to ignite a flammable gas mixture. Purged and pressurized systems use positive pressure to keep flammable gases out of the enclosure. Non-incendive equipment is designed so that it will not produce a spark or hot surface capable of igniting a flammable gas mixture. The selection of the appropriate type of equipment depends on the specific application and the level of risk. It is important to consult with a qualified electrical engineer to determine the correct equipment for the application. The National Electrical Code, NEC, provides detailed requirements for electrical installations in hazardous locations. Article 500 covers the general requirements for hazardous locations. Articles 501 through 504 cover the specific requirements for different classes and divisions of hazardous locations. The NEC also provides information on the selection and installation of explosion-proof equipment. It is important to follow the NEC requirements carefully to ensure a safe installation. In addition to the NEC, other standards may also apply to electrical installations in hazardous locations. These standards may include those published by the Institute of Electrical and Electronics Engineers, i.e., the Instrument Society of America, ISA, and other organizations. It is important to be familiar with all applicable standards before beginning an installation. Proper training is essential for personnel who work in hazardous locations. Training should cover the hazards of flammable gases, the requirements for electrical installations in hazardous locations, and the proper use of explosion-proof equipment. Personnel should also be trained on how to respond to a gas leak or other emergency. Regular inspections and maintenance are essential for ensuring the continued safety of electrical installations in hazardous locations. Inspections should be performed by qualified personnel. Maintenance should be performed in accordance with the manufacturer's recommendations. Any damaged or defective equipment should be repaired or replaced immediately. The use of gas detection systems in conjunction with proper area classification and explosion-proof equipment can provide a high level of safety in areas where flammable gases are present. However, it is important to remember that gas detection systems are not a substitute for proper design and installation practices. It is important to consult with a qualified professional to ensure that the installation meets all applicable requirements. The specific requirements for electrical installations in hazardous locations vary depending on the class, division, and group of the location. It is important to understand the differences between these classifications in order to select the appropriate equipment and installation methods. Class I locations are those in which flammable gases or vapors are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Class II locations are those in which combustible dust is or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Class III locations are those in which easily ignitable fibers or flyings are present, but not likely to be in suspension in the air in quantities sufficient to produce ignitable mixtures. Division I locations are those in which ignitable concentrations of flammable gases, flammable liquid-produced vapors, or combustible liquid-produced vapors can exist under normal operating conditions. Division II locations are those in which ignitable concentrations of flammable gases, flammable liquid-produced vapors, or combustible liquid-produced vapors are present, but under abnormal operating conditions. Group A atmospheres contain acetylene. Group B atmospheres contain hydrogen or gases or vapors of equivalent hazard such as manufactured gas. Group C atmospheres contain ethyl ether, ethylene, or cyclopropane. Group D atmospheres contain acetone, alcohol, ammonia, benzene, benzol, butane, gasoline, hexane, lacquer solvent vapors, naphtha, natural gas, propane, or gases or vapors of equivalent hazard. The selection of electrical equipment for use in hazardous locations must be based on the class, division, and group of the location. Electrical equipment that is approved for use in one class, division, and group may not be suitable for use in another class, division, and group. It is important to consult the manufacturer's instructions and the applicable codes and standards to ensure that the equipment is suitable for the intended application. In summary, the definitive sources clearly indicate that indoor areas with natural gas require Class I, Division II classification. Gas detectors can supplement safety measures but cannot replace the need for explosion-proof equipment and adherence to NFPA 70, ANSI/NFPA 30, and AGA standards. Understanding the specific requirements for hazardous locations and selecting the appropriate equipment are crucial for ensuring a safe installation. Proper training and regular maintenance are also essential for maintaining the safety of electrical installations in hazardous locations. Remember to consult with qualified professionals and adhere to all applicable codes and standards to ensure safe and compliant installation. Ignoring these requirements can lead to serious consequences, including explosions, fires, and injuries. Therefore, prioritizing safety and following established guidelines is paramount when dealing with natural gas and hazardous locations. The National Fire Protection Association, NFPA, provides a wide range of codes and standards related to fire safety and electrical safety. These codes and standards are widely used and recognized throughout the world. The American National Standards Institute, ANSI, is a non-profit organization that develops and publishes voluntary consensus standards. ANSI standards cover a wide range of topics, including safety, performance, and quality. The American Gas Association, AGA, is a trade organization that represents natural gas utilities. The AGA develops and publishes standards related to the natural gas industry. These organizations provide valuable resources and guidance for ensuring safety in areas where flammable gases are present. By following their recommendations and adhering to applicable codes and standards, you can minimize the risk of accidents and protect people and property. It is important to stay informed about the latest developments in safety standards and technologies. Regularly review and update your safety procedures to ensure that they are in line with current best practices. Participate in training programs and attend industry conferences to learn about new safety measures and technologies. By staying informed and proactive, you can create a safer working environment and reduce the risk of accidents. In addition to the technical aspects of hazardous location safety, it is also important to consider the human factors involved. Human error is a common cause of accidents in hazardous locations. Therefore, it is essential to implement procedures and training programs that minimize the risk of human error. These procedures and training programs should cover topics such as proper operating procedures, emergency response procedures, and the importance of following safety guidelines. It is also important to create a culture of safety in the workplace. This means encouraging employees to report safety concerns and providing them with the resources and support they need to work safely. By fostering a culture of safety, you can create a safer and more productive work environment. The initial question refers to the installation of a natural gas compressor with operating pressures ranging from 95 psi to 240 psi. These pressures are significant and contribute to the potential hazard in the event of a leak. The higher the pressure, the greater the potential for a rapid release of gas and the formation of an explosive atmosphere. The question also mentions an associated cooler for the natural gas compressor. The cooler is likely used to reduce the temperature of the compressed gas, which can increase its density and potentially increase the risk of an explosion. The presence of both the compressor and the cooler in an indoor location further exacerbates the hazard, as it confines any potential gas leaks and allows the concentration to build up more quickly. Given these factors, it is clear that a thorough assessment of the hazardous area classification is essential to ensure the safety of the installation. The client's desire to avoid explosion-proof devices based solely on the use of gas detectors is a risky proposition. While gas detectors can provide an early warning of a gas leak, they are not foolproof and should not be relied upon as the sole means of protection. As previously mentioned, gas detectors can fail, and there may be delays in response time. Furthermore, gas detectors only detect the presence of gas. They do not prevent the release of gas or mitigate the potential for an explosion. The use of explosion-proof devices, on the other hand, provides a passive layer of protection by containing any potential explosions within the device enclosure. This prevents the explosion from propagating to the surrounding atmosphere and potentially causing a larger incident. Therefore, the combination of gas detectors and explosion-proof devices provides a more robust and reliable safety system. It is important to consider the overall risk assessment when determining the appropriate level of protection for a hazardous location. The risk assessment should take into account factors such as the likelihood of a gas leak, the potential consequences of an explosion, and the effectiveness of the safety measures in place. Based on the risk assessment, you can determine the appropriate hazardous area classification and select the appropriate equipment and installation methods. In addition to the codes and standards already mentioned, it is also important to consult with the equipment manufacturers for their recommendations on the safe installation and operation of the natural gas compressor and cooler. The manufacturers may have specific requirements or recommendations based on the design and performance of their equipment. Following these recommendations can help to ensure that the equipment is installed and operated safely. Finally, it is important to document all of the decisions made regarding the hazardous area classification and the selection of equipment and installation methods. This documentation should include the risk assessment, the applicable codes and standards, the equipment manufacturer's recommendations, and any other relevant information. Maintaining thorough documentation can help to demonstrate that you have taken all reasonable steps to ensure the safety of the installation and can be valuable in the event of an incident. Remember that safety is always the top priority when working with flammable gases and hazardous locations. Taking the time to properly assess the risks and implement appropriate safety measures can help to prevent accidents and protect people and property. The information provided by the NFPA, ANSI, and AUGUR combined with sound engineering judgment and a thorough understanding of the specific application, can help to ensure a safe and compliant installation. Class 1. Division 2 locations are defined as areas where flammable gases or vapors are handled, processed, or used, but are normally confined within closed containers or closed systems from which they can escape only in case of accidental rupture or breakdown of such containers or systems, or in case of abnormal operation of equipment. Also, locations in which ignitable concentrations of gases or vapors are normally prevented by positive mechanical ventilation, but which might become hazardous through failure or abnormal operation of the ventilating equipment, and locations that are adjacent to Class 1, Division 1 locations, and to which ignitable concentrations of gases or vapors might occasionally be communicated unless such communication is prevented by adequate positive pressure ventilation from a source of clean air, and effective safeguards against ventilation failure are provided. The installation of a natural gas compressor and its associated cooler inside a building typically falls under the Class 1, Division 2 classification due to the potential for gas leaks even with proper handling in closed systems. The pressure range of 95 psi to 240 psi further increases the potential risk, necessitating appropriate safety measures. Gas detectors, while beneficial for alerting personnel to leaks, do not replace the fundamental requirement for explosion-proof equipment in Class 1, Division 2 environments. Explosion-proof equipment is designed to contain any internal explosion, preventing it from igniting the surrounding atmosphere. This passive safety measure is crucial for preventing catastrophic events. The relevant standards, including NFPA 70, ANSI/NFPA 30, and AGA guidelines, clearly specify the requirements for electrical installations in hazardous locations. These standards emphasize the use of explosion-proof equipment and proper ventilation to mitigate the risks associated with flammable gases. Ignoring these standards can lead to severe consequences, including fires, explosions, and injuries. Therefore, it is essential to adhere to the recommended safety measures and consult with qualified professionals to ensure compliance. The National Electrical Code, NEC, Article 500 through 516 provides detailed guidelines for electrical installations in hazardous locations. These guidelines cover various aspects, including equipment selection, wiring methods, and grounding requirements. The NEC also provides specific requirements for different classes, divisions, and groups of hazardous locations. Understanding these requirements is crucial for ensuring that electrical installations are safe and compliant. The ANSI/NFPA 30, Flammable and Combustible Liquids Code, provides additional guidance on the storage, handling, and use of flammable liquids and gases. This code covers topics such as ventilation, fire protection, and spill control. Adhering to the requirements of ANSI/NFPA 30 can help to minimize the risk of fires and explosions in areas where flammable substances are present. The American Gas Association (AGA) provides specific guidelines for gas utility areas. These guidelines cover topics such as area classification, ventilation, and electrical installations. Following the AGA guidelines can help to ensure that gas utility areas are safe and compliant. In addition to these standards and guidelines, it is also important to consider the manufacturer's recommendations for the safe installation and operation of the natural gas compressor and cooler. The manufacturer's recommendations may provide specific details on equipment selection, installation procedures, and maintenance requirements. Adhering to these recommendations can help to ensure that the equipment is operating safely and efficiently. The location in Mission Viejo, California, is subject to California's built-in codes and regulations, which are often based on or adopt national standards like those from NFPA and ANSI. Local authorities having jurisdiction or ODGs may have additional requirements or interpretations that need to be considered. Always verify local codes and permit requirements before commencing any installation. In conclusion, the safest and most compliant approach is to classify the indoor area as Class 1, Division 2 and implement the necessary explosion-proof measures, irrespective of the presence of gas detectors. Gas detectors can serve as an additional layer of safety, providing early warning of leaks, but they should not be considered a substitute for the fundamental requirements of hazardous location classifications. By adhering to the relevant standards, consulting with qualified professionals, and prioritizing safety, you can ensure a safe and compliant installation. Remember that the well-being of personnel and the protection of property should always be the primary concerns.